And welcome back to another geography lesson. Today we're going to continue with the map work. We looked at the calculations in the previous episodes, and we looked at our topographical map and our orthophoto map. And in the beginning, once we discussed it, if you look at our topographical map, it's got the scale of 1 to 50,000 over there. And then before we continue doing the calculations, we talked and discussed about the clues that we can find on the map to be able to identify certain things. And same goes for our orthophoto. Now keep in mind, our orthophoto has got a much smaller scale, 1 to 10,000, but in reality it's 5 times bigger than the topographical map, because the topographical map's been reduced 1 to 50,000 times, and the orthophoto has only been reduced 10,000 times. But what makes an orthophoto so special, it's got information on it, it's got contour lines on it, it's got places names on it. So it's more information than your normal vertical aerial photograph. Now, if you look at our first slide, and what we're going to do in this episode, we're going to concentrate how we apply what we've learned in the theory to the topographical map and the orthophoto. Now, I'm talking about the section regarding climatology, geomorphology, and settlement, as well as economic geography. But let's just quickly look first at climatology. Now, for instance, one of the questions that may pop up: which slopes are the warmest? Now, first of all, when we've learned about local climate, we looked at aspect. And I'm just quickly going to draw it over there for you. And when we looked at aspect, right, there's our north-facing slope and there's our south-facing slope. So the north-facing slope is facing towards the equator, and it receives more insulation, more concentrated but more direct insulation. Our south-facing slopes are more oblique. As you can see, it's been cast in a shadow. So won't experience that warm temperatures as on the north-facing slopes. And the chances that you're going to get a map with slopes is very good. Now let's just quickly look at the pole map. If you look at the pole map over here, now if you look at this area over here where we have the pole granite domes, you will see, now remember, before I'm going to continue, where's north? North is always on top of your map. So this areas, you will see that most of the people would rather settle on the north-facing slopes than the south-facing slopes, because they receive more insulation, and that's where settlement will take place. Now, if we look at the next question, if you look at the answer, which slopes are the warmest? We already determined it, the north-facing slopes, because they're facing towards the equator, so we will experience warmer temperatures on the north-facing slopes. Now, which slopes are the coldest? Now, the south-facing slopes, facing away from the equator, and I've shown you over here, as you can see over there, the south-facing slopes, away from the equator, it's cast in the shallow area. They won't receive as much insulation like the north-facing slopes. So very importantly, when you do get a question regarding aspect in your topographical map, go and look at the slopes, and you will see possibly that more people will settle on the north-facing slopes than the south-facing slopes. If you look at our next question, we did look at our next question, why are there more houses and plantations on the slope of a valley? Once again, what are we discussing over here? We're discussing local climate. Now let's just quickly draw our valley. Now there's our valley. Now during the climatology section, we learned about two breezes, katabatic and anabatic breezes. Anabatic breezes is upslope winds that moves up the slope during the day, And during night time, we experience katabatic breezes when the air sinks to the bottom of the valley. Now the question states, and if you look on the map, that you will find that most of the settlement and farming activities are taking place halfway up the slope. And the reason for that is, and we looked at that during our climatology section, is because of what happens during night time. We discussed it. The cold air sinks down to the bottom, to the floor of the valley floor. What does it do with that warm air? It displaces the warm air, creating the inversion layer or the thermal belt. And the reason why the farmers would rather farm in these areas over there and rather build their settlements over there is because of the warmer conditions. Now keep in mind, the reason why farming takes place over there, because what develops on the bottom of the valley? The frost pocket. Okay, because there's a problem. Not many plants are frost resistant, so they rather plant upslope where there's warmer temperatures and it won't do any damage to their crops. Now question number 3, determine which slope faces north. We've just done that. And the plants grow better. If we look at question number 4, I believe I've just answered that almost as well. Where will the thermal belt occur? Determine where the valley is and where halfway up the valley would be. So, oops, this thing keeps on jumping. Where will it happen? Now, I've indicated over here, halfway up the slope, this is where the thermal belt is. Now, what is the inversion again? It's an increase with temperature with an increase with altitude. Because it's cold over here and the temperature increases. It's a negative lapse rate. So the thermal belt will be halfway up the slope. And like I've mentioned, that's where people will plant their crops, because many crops are not frost resistant, and people will build their settlements because it's a warmer area. Now, if we quickly go back to the map, now if you look at some of the areas over there, as you can see, these are quite flat areas. Now, as you can see, there is quite a steep slope situated over there, and you can see construction doesn't take place where the steepest slopes are. Why? Because it's cheaper, because it's flat land, and as you can see, it's much easier to farm where the flat land is. But I quickly want to get you an example of valley breezes, and then we need to quickly move to the town of Ceres of Paul. As you can see, the contour lines are quite close to one another over there. Now that is steep. Settlement takes place halfway up the slope. There's a river right in the bottom of the valley. Now most of this area that's over there is not where settlement takes place, but rather industries, because of the need of the water. But most of your residential settlements will be up here because it's warmer conditions. Okay. Let's continue with our questions. Where will the frost occur? Determine where the bottom of the valley is. Frost pockets occur at the bottom of the valley. Now, for instance, if we go back to the map, as you can see, the town of Paul is situated in a valley. This is basically halfway up the slope. As you can see, no farming activity is taking place very close to the Berg River because of frost that might be experienced, especially during winter. But keep in mind, they can plant crops if they are frost resistant. Now this is quite an interesting question, and I do see this question quite a lot of times in the final exam. Does the area experience high rainfall? Determine the amount of cultivated land and the number of perennial rivers. Now that's the number of rivers that flow all year round. Now, before grade 12, you've only known about two rivers. A non-perennial river, that's seasonal rainfall, and a perennial river that flows all year round. But let's just quickly go and have a look at the area of Paarl. I'm going to use an example. We see a lot of cultivated land. Okay, that's our first tip. But can we ultimately say that it's an area with high rainfall? Not always, because as you can see, there's a lot of dams that's been constructed. And these dams are there to store water. But if you look at many of the rivers on here is perennial rivers. It's a solid blue line. It's a permanent river. But what do we see as well? We do see non-perennial rivers as well. So non-perennial rivers means it only flows during seasonal rainfall, and when it receives its rainfall during high rainfall areas. As you can see, the Berg River over here, clearly you can see it's a permanent river. And to be able to know if the river is permanent or not, you just need to go to your references. As such, you can see a solid blue line represents perennial rivers, a dotted blue line represents non-perennial rivers. And another clue on this map that we looked at, if you do not know where Paarl is, usually you will see on the outskirts it leads to major towns or cities. Cape Town is 57 kilometers away, and we know Cape Town is in the Western Cape Province. And we know that the Western Cape Province experiences Mediterranean rainfall, and most of the time they experience their rainfall in the winter. So we know this area experiences seasonal rainfall. So there is a tip for you. So basically we're going to just have a look. If there's many perennial rivers, we know flow all year round, it might be an indication that it's a high rainfall area. If there's many non-perennial rivers, might mean seasonal rainfall. It can be a dry area, depending where the area is. And we look at the drainage density as well. Density, keep in mind, we get two different types of density. Now, a stream that you see with a lot of surface runoff with many tributaries is a high density area, drainage density. And for instance, a stream, river with only a few tributaries is going to be a low density. Now, as you can see, high rainfall areas have lots of cultivated land, many perennial rivers, and a high drainage density. Now, this we will usually find in places very close to the equator, but in South Africa, definitely KwaZulu-Natal. KwaZulu-Natal's got quite a high rainfall per year, as well as a certain section in South Africa close to Knysna and Plettenberg Bay. But most of South Africa experience seasonal rainfall. Now, if we move to provinces such as the Northern Cape, the area will experience low rainfall because you won't see many cultivated land over there. People don't farm because the land is not fertile enough. It's not arable because it doesn't receive enough rainfall. And there's not many perennial rivers, so basically most of them will be non-perennial rivers. And there will be only the total number of rivers in the area, the density is going to be extremely low. And if we continue, low rainfall areas have very little cultivated land, like we've just mentioned. Okay. Now, this one over here, point 8, does the area experience seasonal rainfall? And in the most cases, South Africa, do we experience seasonal rainfall? We either experience winter rainfall like the Western Cape area, or we experience summer rainfall like the Highveld up in Johannesburg and surrounding areas such as Free State and Northwest. Now you will see there's many non-perennial streams flowing, rivers, but very importantly, the construction of dams and furrows. Now, if you quickly go back, you can see many dams that's been constructed. And next to the dams you will find the cultivated land. Now the purpose of these dams is for irrigation purposes because they only receive rainfall during a certain period, so they needed water to water their crops even further. They do not receive water all the time. Very importantly as well, you can see reservoirs as well. People build water towers, reservoirs, when water is scarce or when a place receives seasonal rainfall. Now, if you just quickly look at some characteristics of seasonal rainfall, it's areas that have mostly non-perennial rivers, many dams, like I've mentioned, and cultivated land will be very close to the dam and the perennial rivers. So we just looked at the characteristics to look for on a map regarding climate. After the break, we're quickly going to go and focus on geomorphology and look at some characteristics that we can see on a map that you've learned in your theory section of geomorphology. Stay tuned. See you in a bit.